Well, in this lecture, I am going to spread some light on the calculation of t statistic. And before going to the calculation part, I like to spread some light on the t-test. What is t-test? You know it very well. What is t-test? A t-test, it is also known that the student's t-test is a tool. You know, t-test is a tool for evaluating the means of one or two populations using hypothesis testing. Okay. A t-test may be used to evaluate if a single group differs from a known value. If two groups differ from each other, or if there is a significant difference in paired measurements. Okay, so this is the t-test, you know. And how are t-tests used? As an example, we can mention here is that when comparing two populations, you might hypothesize that their means are the same, and you decide on an acceptable probability of concluding that a difference exists when that is not true. After that, you calculate a test statistics from your data and compare it to a theoretical value or the table value from a t distribution. Depending on the outcome, you either reject or fail to reject your null hypothesis. Okay. You can't use a t-test, okay, when when you have more than two groups. When you have more than two groups, there are some assumptions, you know. There are some assumptions, and look at these assumptions. The data are homogeneous. Data are homogeneous. Just a moment. The data are continuous, and the sample data have been randomly sampled from a population. There is homogeneity of variance. There is homogeneity of variance, okay? And the distribution is approximately normal. The distribution is approximately normal. So there are near about four assumptions. The data are continuous, and the sample data have been randomly sampled from a population, and there is homogeneity of variance, and the distribution is approximately normal. For two sample t-tests, you must have independent samples. Must have independent samples. If you have two groups, one group must differ from other groups. Okay. If the samples are not independent, then a paired t-test may be appropriate. Now, I am going to the calculation part. Okay, look. By using the Excel, you can calculate this. Look, this is the outcomes of field 1 and field 2. There are 16 outcomes. There are 16 outcomes. And to find out the t value, we have to follow this formula. And what is the formula? The formula is the mode of difference between the mean of the two groups and square root of the sum of the variance divided by the number of observations and variance of group 2 divided by the number of observations of that group. Okay, so this is the formula. Depending on the formula, we are going to calculate the t value. And What is the null hypothesis here? The null hypothesis is that mean of field 1 is equal to the mean of field 2. And alternative hypothesis is that the mean of field 1 is not equal to the mean of field 2. So now we are going to check it, whether the null hypothesis is accepted or not. So following this formula, we have to first calculate the mean of these values. The mean of these values here, the mean of these values is this, equal to average is the mean, average to calculate this. Okay, so this way 14 is the mean of the field 1, and here again we average, double click here, and you have this. Okay, here. Okay, now the standard deviation, we have to find out the standard deviation of the field 1. So equal to STDV, that's the deviation. Just a moment, standard deviation is here, double click here and select this column and click okay, standard deviation. Now here we are going to find out the standard deviation of field 2. Okay, so this one. Now the variance, you know the variance, the square of the standard deviation is, and again we multiply this. So the variance is the variance, and now again the variance of field 2, this multiplied with this again. Okay, so now, so this is the calculated part. Now look, now we have to find out the difference between the mean and the mode. So I can calculate in this way. Look at this, equal to this part minus this part. Okay, 4, 5, and if you take the mode, then 0.45. Okay. Okay. Now this part, we have calculated this part. Now the variance divided by the standard divided by the number of observations. What are the variance? Variance is this 5.13 for field 1 and 0.070 for field 2. So, and we have to divide it. Look, this is the, I am calculated again here, equal to this divided by 16. Okay, this one, and this is the this part, now this part equal to variance of for field 2 by 16. Okay, so this, now we have to sum it, these two values equal to this plus this one. Okay, so this, and ultimately we have to take the square root of this, then we get the denominator of this. Okay, p value. So square root equal to square root of this value. Okay. So this is the 0.60, this value 0.60. So we have to divide 0.45 by 0.604391. So look here, equal to this divided by this one. Okay, so this is the t value, this is the t value. Okay, so in this way, in Excel you can calculate the t value. Now I am going to shed some light on an example, and that example you can do in your exercise book. Okay, so look at this. Look at this. Here is the problem. Compute t-test for the data given below. And there are two groups in the problem. And in group A, there are 10 values. Okay. And in group B, there are also 10 values. And critical value is given at 5% level. And critical value is given for 10% level. And you have to find out the t value. And also you have to conclude that whether the null hypothesis is accepted or not. Okay, so look, there is you can find the solution in this way, that the values of group A is here in the row Y, so we have to cover it along the column wise, and group B, the values of group B also along the column wise. And look, this is the okay. Now we have to find out the mean because we have to follow the formula for calculating the t-value. The formula for calculating the t-value is t equal to x1 bar minus x2 bar divided by the standard deviation. Okay, multiplied with the square root of n1, n2 divided by the n1 plus n2. N1 is the number of observation for group A, and N2 is the number of observations for group B. Okay, and we have these values, but X, we do not have the S values of S. So we have to calculate the value of S following this formula. Look, S equal to square root of the summation x1 minus x1 bar whole square plus summation of the whole square of x2 minus x2 bar divided by the n1 plus n2 minus 2. Okay, so look, now, so x1 bar and x2 bar you have to calculate. So we are going to calculate. At first, we have to calculate the sum equal to sum of these values, then divide it by this divided by 10. So 5 is the mean for group A. And here also we have to calculate the sum of these values, okay, and to get the mean you have to calculate 5. Okay, so 7.7 is the mean for group B. Now we have to subtract the 5 from each element of group A and 7.7 from each element of group B in this column. Okay, so I have written in this way, and you can find it in this way, equal to 8 minus 5 equal to 3, and equal to 6 minus 5 equal to 1. So in this way you can proceed, or in Excel you can drag it. So these values are there. And in the same way, you have to subtract the 7.7 from 4, for 7, from 8, from 3, from 8, in this the same way. Okay, look at this formula. Okay, so this again the same. Okay, so now I have done all these things. So this, okay. Select. I'm calculating it again. Okay. Now I have to take the square of each element of this column. Okay. So 3 square of 3 is 9, 1 of square of 1 is 1. So in this way, square of this column, each element of this column. So this is the value. Now the square of these values is here in this column. Now I am taking this in my table. Okay. So now I have to take the sum of these values, because here equal to sum of these values. Okay. So 26. Now sum of this value. Sum. Okay. 160.1, because we have to calculate this S value. And as we have to calculate this S value, we require this part x1 minus x1 per whole square, x1, x2 minus x2 per whole square, and also the sum of this value, So this is the value 26. 26 is the sum of x1 minus x1 per whole square, and 160.1 is the sum of x2 minus x2 per whole square. Clear? So now we have to find out the S value. At first, we have to find out the S value. So we have to take the sum of these values. We have to take, look, the sum of two values equal to this plus this one. Okay, 186.1. So 186.1. The same thing is here. Now we have to divide it. By the n1 plus n2 minus 2. That is 10 plus 10 minus 2. That is 18. That means equal to this minus 18. Okay. So 10.33. Okay. So now we have to take the square root of this. Okay. So square root of this is, I can write it in this way, 10.34. Okay. Now 10.34 and square root of this are, just a moment, equal to square root of this. Okay. So 3.21 or 3.22 is the standard deviation. Okay. Now the t value. Look, t value can be calculated by following this formula, and this formula is here. You can find that this is the x1 bar minus x2 bar divided by s. Okay. What is the x1 bar? X1 bar is 5, x2 bar is 7.7. And if you take the mod of the difference, that is the 2.7. So 2.7, you have to divide the 2.7 by 3.22. 3.22 is the standard deviation. So we have this value, 0.83 or 0.84. Okay. Now the t value. Because we have to multiply this part with this part. N1 multiplied with N2, that is 10 multiplied with 10 is 100, divided by 10 plus 10, that is 20, it is 100, and 100 by 20 is equal to 5, and square root of 5, look, equal to square root of 5 is equal to 2.236 and 2.24. Okay, so the t value is this part equal to this part multiplied with this part, 1.80. So t value is the 1.80. Now For a better understanding, I am going to a, this part. Look at this. This is the normal distribution curve. Okay, normally distributed. And if this is this part, you look here, you can find the this is the mean, okay, and here this point, look at this very carefully. This point is the critical value, and this is the rejection region. If it may be 1% level, and it may be 5% level, whatever you like to take, you can take. So this is the rejection region in our example, and if the p-value, the calculated p-value lies in this region, then you have to reject the null hypothesis. Okay, and if it does not lie in this region, then you have it lies here in it lies here, then you can accept. So the critical value in this example is 2.15. If you consider 2.15 at 5% level, and it is 2.15 at 5% level, it is 5% level, for example, our t-value, calculated t-value is 1.88, and our table value is 2.15. So it is less than 1.8, it is less than 2.15. So it lies here to the left of this vertical line, So we could not be able to reject the null hypothesis. Rather, you accept the null hypothesis. What is the null hypothesis? Mean of the two values are mean of the two groups are same. Okay. And if we consider another line here, okay. Suppose here I am drawing another line. This is 1% level. This is suppose this is okay. Just a moment. Look at this point. Okay, this is the 1% level. This is the critical value. This is the critical value. This is the rejection region. If you consider 1% level, and if you consider 1% level, the critical value is 2.89. So this is the 2.89. I am writing here for a better understanding. Okay, I am writing here. This is 2.89. Okay, this is 2.89. This is 2.89, and this is 2.15. Okay, so this is the critical value for 1% level, and the 1.88, the calculated p-value, this statistic is 1.88, and it is also to the left of this vertical line. It does not lie in this rejection region, so we could not be able to reject the null hypothesis. So rather we have to accept the null hypothesis. So here look at this. Here the calculate, it is asked in this problem that compute the t-test. So the value of the t-test is 1.88, and we have to accept the null hypothesis. Okay, because it is significant at 1% level as well as at the 5% level. Okay, so I hope you have enjoyed this lecture, and this lecture all about the t statistics, and how to calculate the t statistics in Excel. I have tried to focus on this point, and if you like to solve these questions, if these questions is in your examination, then you can also calculate in your answer script, in your answer scripts by using the simple calculator. Okay, so this is all about the t statistics. Thank you for enjoying this lecture.